Time is not a river, at least not in the way we usually imagine. It does not simply flow from past to future like water running downhill. Out here, beyond the glow of our cities, beyond the warmth of our sun, time stretches, bends, and folds itself across billions of years. Out here, the difference between one moment and the next can be the span of civilizations, the rise and fall of stars, the passing of travelers no human eye was ever meant to see. And yet, tonight, you and I are about to follow in their path. We are about to stand at the edge of something vast, where the familiar rules of everyday life dissolve into the cosmic mystery of wandering worlds. Welcome, dear traveler, to the sleepless how. This is your space, a place where we stay awake together in the endless night, listening for whispers carried across light years. I am grateful you've joined me here. If the journey ahead speaks to you, if you find beauty in the questions that have no easy answers, I invite you to share your presence by subscribing, by leaving your quiet mark. Each gesture of connection helps keep this space alive, and I thank you deeply for it. Now, let us begin. Across the history of our skies, humanity has grown used to the familiar, planets orbiting in their predictable ellipses, comets returning on their appointed centuries, asteroids bound like loyal children to the gravity of our star. These are the neighbors we know, the residents of a solar system that has carried us safely through 4.5 billion years. But from time to time, something else arrives, something unbound, uninvited, crossing the borders of our neighborhood, like a traveler from another city whose name we cannot yet pronounce. We call them interstellar visitors, objects that were not born here, that owe nothing to our sun, that carry with them the dust of alien nurseries and the long silence of a billion-mile road. So far, we have seen only two such wanderers up close. The enigmatic Oumuamua, thin as a blade and strange as a forgotten dream, and Tuai Borisov, a comet that blazed briefly before fading back into night. But now, against all odds, we stand at the threshold of a third encounter. A newcomer, stranger still, with whispers of a story that may reach farther than we ever dared to believe. The object has been given a name, 3I Atlas. At first glance, it is a comet trailing its veil of gas and dust as it arcs across the dark. Yet beneath that familiar disguise lies a strangeness that sets it apart from all we have known before. Astronomers are only beginning to trace its origins, to measure the oddities of its chemistry, to compare its restless brightness with the quiet core hidden inside. But before we even begin to peel back those mysteries, there is something more haunting, more alluring, waiting just beneath the surface of this discovery. Because 3I Atlas does not simply appear from nowhere. Its path across our sky points us toward a region of space already etched into human memory, the constellation of Sagittarius, near the center of our galaxy. And it was from that same celestial neighborhood, nearly 50 years ago, that a signal once reached Earth, a signal that has never been explained, never been repeated, but has lingered in our collective imagination like a beacon from the unknown. They called it the WOW signal. A burst of radio waves so sharp, so unlikely, so precisely tuned to the frequency of hydrogen, the building block of life itself, that one astronomer scrawled "Wow" in the margins of the datasheet, a note of astonishment that gave the signal its enduring name. It lasted 72 seconds, then it was gone. Half a century later, no one can say with certainty what it was. But tonight, as we open this story, we feel its echo, a third interstellar traveler, a path aligned with the memory of a message, a coincidence perhaps, or perhaps not. The sleepless how is not a place for easy answers. It is a place for questions, questions that shimmer like starlight at the edge of sight, questions that keep us awake when the world would rather fall asleep. So let us walk together into the mystery of 3I Atlas, into the possibilities it offers, into the long threads of time that bind a fleeting visitor to a half-century-old whisper from the stars. Think of what it means, an object born beyond our sun, carrying the fingerprints of a star system we may never visit, arriving just as our instruments are finally sharp enough to read its story. Think of the timing, the synchronicity, the way our species stands now more awake than ever before, able to measure frequencies that once slipped past unnoticed, able to capture images of comas and tails that unfold across tens of thousands of kilometers. What might we learn from this wanderer? What truths lie hidden in its strange proportions, its unexpected chemistry, its journey across the heart of Sagittarius? Perhaps it is nothing more than chance. Perhaps the wow signal was a quirk of our own machines, and this comet merely another frozen relic cast adrift in the galaxy's tides. Yet even chance can feel like destiny when it arrives in just the right moment. Even coincidence can leave us wondering whether the universe is speaking in a language too vast for us to fully hear. In the nights ahead, we will follow this story together. We will trace the paths of astronomers who first glimpsed the speck of light that betrayed 3i Atlas's arrival. We will listen to the hum of telescopes tuned to its breath, to the colors of its dust and gas, to the silent mathematics of its orbit. We will compare its strangeness to the wanderers that came before, and we will ask what its presence might mean for us, here on our fragile world, awake under the stars. The stage is set. The sky has opened. A mystery approaches. The mystery of 3i Atlas begins not in the present, but in a summer evening nearly half a century ago. Long before modern space telescopes reached orbit, before computers compressed data into neat visuals, the search for cosmic messages was carried out in quiet rooms filled with humming machines and endless lines of numbers printed on paper. It was August 1977 at Ohio State University. On the campus, hidden behind ordinary walls, sat a great white structure known affectionately as the Big Ear. This was no ordinary observatory. The Big Ear was a radio telescope, an enormous pair of aluminum panels stretching across a field, listening not to light but to the invisible murmur of radio waves drifting down from the cosmos. For years, it had been part of a project dedicated to one of humanity's boldest dreams, the possibility that someone, somewhere, might be transmitting a signal across the stars. On the night of August 15th, the telescope swept its gaze across the constellation Sagittarius. The data, captured by machines, did not appear as glowing points of light. Instead, it streamed out as numbers and letters on long sheets of computer printouts. To most eyes, these sheets were meaningless, rows upon rows of digits, endless sequences of data, but to one man, they would become the stuff of legend. Jerry Amon, a volunteer for the SETI project, sat with those printouts a few days later. He was not expecting anything extraordinary. Years of searching had taught researchers that cosmic noise was fickle, fleeting, rarely more than interference or the chatter of natural sources. Yet as his eyes traveled down the page, a sequence leapt out at him. The numbers surged upward, far beyond the usual static, culminating in a combination of characters so precise, so striking, that he grabbed a red pen and circled them. In the margin, almost involuntarily, he wrote a single word: wow. That one exclamation, scrawled in haste, would forever name the most famous mystery in the search for extraterrestrial intelligence. The signal lasted for 72 seconds, the length of time it took the Big Ear's fixed beam to sweep across that region of the sky. Then it was gone. No fading, no echo, just silence. It had come from the exact frequency of 1420 megahertz, the emission line of neutral hydrogen. This detail alone set pulses racing. Hydrogen is the most abundant element in the universe, the very foundation of stars and life. For decades, scientists had speculated that if any intelligent civilization wished to announce itself, it might choose to broadcast at that frequency, the one place in the spectrum any curious species would be certain to check. The wow signal seemed to fit that expectation with uncanny precision, strong, narrow, unmistakably unusual, and arriving from the heavens at exactly the right cosmic channel. No natural source was known to produce such a clean spike. No satellite had been in that line of sight. No terrestrial interference matched its profile. For those 72 seconds, the universe felt suddenly less empty. Yet when researchers returned to the sky, pointing telescopes again and again at Sagittarius, nothing appeared. The wow signal has never repeated, not once, in nearly 50 years of searching. This silence only deepened the mystery. If the signal were artificial, Why was it sent only once? If it were natural, why had no similar burst ever been found? Over the decades, theories multiplied. Some suggested it was a transmission from an alien civilization. Others argued it might have been a reflection from a passing comet, or the glint of a satellite signal bouncing in an odd way. Yet none of these explanations fit neatly. Each required compromises, unlikely coincidences, or left lingering gaps. The only certainty was its direction. The big ear had been fixed in place, its massive panels incapable of tracking like modern dishes. It could only scan as the Earth rotated. From the data, astronomers knew that the signal had originated in the constellation Sagittarius, near the dense heart of the Milky Way. This detail was almost poetic. The galactic center, where stars crowd more tightly than anywhere else in the sky, has long been a place of speculation and myth. To receive a signal from there was to feel as though the very core of our galaxy had stirred and whispered. Picture that summer evening again, the warm air of Ohio, the quiet halls of the observatory, the giant white panels gazing into the night. Somewhere above, light years away, a beam of radio energy crossed the gulf of space and happened to fall upon a field in the American Midwest. A human hand circled it, wrote, "Wow," and for half a century we have lived with the echo of that moment. What made it so haunting was not only the data, but the sense of incompleteness. The signal gave us just enough to imagine, never enough to prove. It was a door cracked open in a darkened room, showing only a sliver of light before slamming shut again. Humanity has built entire cultures upon mysteries less profound than this. The wow signal was real, recorded, undeniable, yet it carried no message, no repeat, no certainty. It left us to wonder whether we had been brushed by the sleeve of another intelligence or merely tricked by the complexity of the universe. As the years passed, the legend grew. The term wow signal entered the vocabulary of dreamers and skeptics alike. It became the rallying cry of SETI, the tantalizing suggestion that the silence of the stars might not be absolute. Every time a telescope tuned to the hydrogen line, there lingered the hope that the sequence might return, that the printout would once again flare with improbable numbers. It never did. Yet the origin in Sagittarius has remained fixed in memory. When astronomers speak of the wow signal, they point not just to the data, but to the sky itself, to that crowded region near the galactic core where millions of stars burn close together. That location has become a symbol, a cosmic landmark etched into our story. Tonight, as we turn our gaze once more towards Sagittarius, it is not only to remember, it is because from that same celestial region, across decades and billions of miles, another visitor has arrived, a comet unlike any seen before, tracing its arc into our solar system. It is here that past and present begin to converge, where the memory of a fleeting radio burst entwines with the arrival of a physical traveler from interstellar space. The wow signal left us with silence, but silence, as we will see, is never the end of the story. The wow signal faded into silence, leaving only the memory of its origin. Yet the direction it came from has never lost its weight. Sagittarius. To many, it is simply a zodiac constellation traced across summer skies, its stars forming the rough outline of an archer drawing back a bow. But to astronomers, Sagittarius holds far deeper significance, for in its crowded expanse lies the very heart of our galaxy, the galactic center, where gravity reigns with unmatched power and mysteries gather like shadows around a flame. Imagine standing at the edge of a forest so vast you cannot see across it. The closer you step toward the center, the denser the trees, the louder the hidden voices of life within. That is what Sagittarius is for the Milky Way. At its center lies a supermassive black hole, Sagittarius A, weighing millions of times more than our sun, wrapped in a cloak of gas, stars, and radiation. To gaze in that direction is to peer toward the core of everything we belong to, the place where countless generations of stars have lived, died, and been reborn. This is why the wow signal's origin mattered. A whisper from Sagittarius was not just a random burst from the sky. It was a voice carried from the densest, richest neighborhood of the galaxy. If one wished to search for messages from civilizations older and stranger than our own, that would be the place to listen. Now consider what it means that, nearly 50 years later, another phenomenon has drawn our attention to this same celestial compass point. Not a signal of radio waves, but a traveler of ice, dust, and unknown chemistry. A comet, unbound, born beyond our solar system, threading its way toward the sun from the very region that once gave us the wow signal. Its name, 3I Atlas. The coincidence is difficult to ignore. Of all the directions in the cosmos, of all the infinite paths a wanderer could take across interstellar space, why should this one arrive from Sagittarius? Why should it echo the coordinates of a mystery that has never been solved? Perhaps it is nothing more than chance. The universe is vast after all, and Sagittarius, positioned near the galactic plane, covers an enormous swath of stars. Interstellar objects could emerge from there simply because so many stellar systems lie along our line of sight. The mathematics of probability would argue that what feels like connection is only alignment, yet even probability cannot strip the poetry from the moment. For to see patterns in the sky is as old as humanity itself. We traced constellations from points of light and imagined hunters, lions, and gods. We stitched myths into their shapes and read meaning in their positions. Now, in the modern era, when we pride ourselves on precision and data, we are reminded that sometimes the sky still writes stories that defy easy dismissal. A comet and a signal, separated by half a century, both pointing us back toward the galactic center. It is tempting to think of the galaxy as a vast sea, its stars as distant islands. In that metaphor, Sagittarius becomes the current, a tide drawing objects and signals alike into alignment. The wow signal was a voice carried on the radio surf. 3I Atlas is a voyager washing ashore from beyond the horizon. Both are messengers, though of very different kinds. One whispered for less than 2 minutes, then vanished into silence. The other will burn brightly for months, trailing its gases into the solar wind before leaving us forever. Both, however, come from the same great tide. The question this raises is not simply whether coincidence or intention is at work. It is what stories we choose to tell about such convergences. Science demands caution, evidence, repeatability. It warns against seeing meaning where there is none. Yet curiosity, the beating heart of discovery, thrives on patterns, on the tantalizing possibility that two unrelated events may, in fact, be chapters of the same narrative. So when we look to Sagittarius and see both the wow signal and 3I Atlas, we cannot help but wonder, is there a thread connecting them? Are they separate accidents bound only by geography? Or is Sagittarius itself trying to tell us something about the nature of the universe? To linger on these thoughts is not to abandon science, but to honor its spirit. For every great breakthrough began with someone willing to ask, what if? What if the wow signal was not interference but a deliberate transmission? What if the arrival of 3I Atlas from the same region is not mere chance, but another kind of message, written not in radio waves, but in the strange chemistry of an interstellar comet? What if the galaxy has ways of speaking we have not yet learned to understand? Think of the wonder of it. Two messengers from Sagittarius, separated by decades, calling our attention back to the galactic heart. One intangible, a fleeting burst of energy across a narrow band of frequency. The other physical, a body of rock and ice, large enough to measure, to photograph, to study, with all the instruments at our disposal. Between them lies a bridge of imagination, connecting past and present, signal and substance, silence and discovery. This bridge builds anticipation, for the approach of 3I Atlas is not an abstract event. It is happening now, unfolding in real time as astronomers track its path through the dark. Each observation sharpens its profile, the size of its nucleus, the scale of its coma, the chemical whispers of its gases. The closer it draws, the more it becomes not just a curiosity, but a revelation. In its details, we may glimpse answers to questions raised long ago by a 72-second burst from Sagittarius. It is here, in this convergence, that the story begins to quicken. The wow signal left us with nothing but silence. 3I Atlas promises spectacle. data, and the chance to touch the unknown with our instruments. As it approaches, we prepare to follow its trail deeper into the mysteries of interstellar visitors. For this is no ordinary comet, no routine visitor bound to the sun. It is something stranger, more elusive, and the first signs of its arrival have already stirred the community of science into excitement. The story of Sagittarius lingered like a pulse at the edge of thought, its echoes reminding us that mysteries often come in clusters, not in isolation. While astronomers debated coincidences and patterns, the sky itself was preparing its next revelation. It did not come as a shout, but as a flicker, a fragile mark across a field of stars. It was May 2025 when the alert first appeared. Far above Earth, in a quiet orbit, the Transiting Exoplanet Survey Satellite, better known as TESS, was carrying out its patient vigil. TESS had not been designed to hunt for interstellar comets. Its mission was something more methodical, more subtle, to watch thousands upon thousands of stars, searching for the slight dimming that occurs when a planet crosses in front of its host. Like a cosmic census taker, it recorded brightness levels with unblinking precision, seeking patterns invisible to the human eye. Yet in science, discoveries often arrive sideways. What Tess noticed was not a planet passing in front of a star, but a faint speck moving where no speck should be. Against the backdrop of constellations that had held their places for millennia, one point of light betrayed itself by shifting ever so slightly between frames. At first glance, it might have been dismissed as a glitch, a piece of noise, an artifact of data. But the algorithms designed to comb through Tess's endless stream of numbers flagged it again and again. Something was out there, moving against the fixed vault of the sky. Detecting such a thing is no small feat. Our solar system is a crowded stage, filled with asteroids and comets, tumbling along predictable orbits. Yet interstellar objects, those wanderers not bound to our sun, are almost unimaginably elusive. They are small, dark, and fast, slipping into view only when chance aligns their paths with our instruments. Spotting one is like trying to notice a firefly darting through the heart of a thunderstorm, its flicker drowned in the lightning all around. Yet somehow, in the spring of 2025, the firefly was caught. Tess had acted like a lighthouse in the dark, sweeping its beams across vast regions of the sky. By comparing the brightness of countless stars over time, it revealed the faintest disturbances, the most delicate shifts. In this case, it had illuminated not a planet, but a traveler, a faint dot betraying its presence through motion. It was, at first, little more than a suspicion, a whisper that something unbound had crossed into our awareness. What made the discovery remarkable was not only the detection itself, but the distance at which it was made. Early estimates placed the object more than 6 astronomical units from the Sun, 6 times farther than Earth, out past Jupiter, still on the cold outer edge of our planetary family. At such distances, ordinary comets remain dormant, frozen solid in the deep freeze of interplanetary space. Yet this object, faint as it was, appeared active. Its coma, a shroud of gas and dust, was already awake, spreading a thin veil around its hidden nucleus. That detail set pulses racing among astronomers. Cometary activity so far from the Sun is rare, especially for small bodies. The heat of our star usually has little effect at such distances, where sunlight is weak and surfaces remain locked in ice. For a newcomer to reveal itself with signs of activity at 6 AU suggested an unusual volatility, a chemistry unlike the comets we know. It was as though the wanderer was eager to announce itself, unwilling to remain hidden until it drew closer. The implications were extraordinary. An interstellar object, already active, already distinct, spotted earlier than either of its predecessors, Oumuamua and Borisov. For once, humanity had time to plan observations, time to mobilize telescopes, time to study a visitor before it rushed past and vanished into the night forever. Word of the detection spread quietly at first, confined to research groups sifting through test data, but soon the murmurs reached the broader community. Emails lit up, observatory schedules shifted, teams began to debate trajectories, brightness curves, orbital possibilities. It was too early for confirmation, too soon to declare the object unbound, but the excitement was unmistakable. Something unusual had entered the stage. Picture that moment. A handful of pixels buried in a sea of numbers, coaxed into meaning by algorithms, then spotted by human eyes trained to suspect the improbable. A speck against infinity, barely distinguishable from background noise, yet carrying within it the potential to reshape our understanding of the galaxy. This is the essence of astronomical discovery, not always dramatic images, but the slow, careful recognition of patterns that whisper from the void. As data accumulated, astronomers began to test their suspicions. The object's faint motion was tracked against the fixed stars, its trajectory slowly teased out. Each night of observation added another point to the arc, another clue about its path. Bit by bit, the evidence mounted. This was no ordinary comet drifting in a long solar orbit. Its velocity, even in those early measurements, hinted at something more profound. Excitement grew, not only because of what it was, but because of how it had been found. TESS, the exoplanet hunter, had once again shown the unpredictability of discovery. Instruments built for one purpose often stumble into revelations their designers never imagined. In the faint glimmer of a moving speck, the telescope had revealed an interstellar visitor, the third of its kind to enter our awareness, but the first to announce itself with such clear signs so far from the sun. The comparison to a firefly in a thunderstorm circulated among astronomers. It captured the improbability of detection, the delicacy of spotting such a fragile glow amid the chaos of cosmic noise. Yet it also carried something more poetic, the image of a small, living light struggling to be noticed in a storm of overwhelming power. That is what the discovery of 3i Atlas felt like. A fragile, improbable flicker that nevertheless carried with it a message from the deep night. The community's anticipation began to ripple outward. Proposals were drafted for telescope time on Hubble, on the James Webb, on ground-based observatories scattered across the globe. Coordinated campaigns were sketched. Collaborations sparked across institutions and nations. Everyone remembered how quickly Oumuamua had come and gone, how little time had been left to gather data. This time would be different. This time the visitor had been seen early at 6 AU, with months to prepare before its closest approaches. Even before formal confirmation, the sense of history was palpable. Here was the third interstellar traveler, discovered not by accident in the night sky through a backyard telescope, but by the vigilant gaze of a spaceborne surveyor scanning systematically, tirelessly, like a lighthouse whose beams never faltered. It was as though the universe had decided to reward patience, to send us a messenger just when our tools were sharp enough to recognize it. In those first weeks, astronomers spoke with the careful restraint of science. Terms like candidate, possible, likely, floated across papers and discussions, but beneath the caution was a current of wonder. For this was not just another rock or ice ball. This was a visitor from beyond, carrying the history of another star system within it, revealed by a flicker of light against the vast canvas of space. The firefly had been spotted. The storm of discovery was about to begin. The firefly had been spotted in the storm, but a flicker alone is not enough. Astronomy demands patience, confirmation, the repeated watching of the sky until doubt yields to certainty. By July 2025, that patience bore fruit. Across the globe, a network of instruments had turned their gaze toward the mysterious speck first flagged by TESS. Among them, the Asteroid Terrestrial Impact Last Alert System, better known as ATLAS, played a decisive role. Designed originally to scan the heavens for hazardous asteroids that might one day stray too close to Earth, the ATLAS telescopes were perched in Hawaii, South Africa, and Chile, strategically placed to cover wide swaths of the sky each night. Their mission was to notice what changed, to see motion where stillness was expected, to track intruders against the canvas of stars. On cool nights in July, ATLAS delivered its verdict. The faint moving dot was no glitch, no artifact, no misinterpreted pixel. It was real, persistent, and measurable. More than that, its behavior revealed something extraordinary. The key lay in velocity. Every object bound to our sun, every asteroid, every comet, every planet, travels within limits imposed by gravity. The sun's pull is immense, stretching far beyond Pluto, dictating the speed at which bodies may move and still remain part of the solar system. To exceed those limits is to escape forever, to fly unbound into the interstellar dark. Astronomers describe this threshold with a simple term: escape velocity. Imagine a child tossing a ball into the air. If the throw is weak, the ball arcs upward, then falls back into waiting hands. That is like an asteroid, destined always to return, looping endlessly around the sun. Throw harder, and the ball climbs higher, lingers longer before descending. That is like a comet, stretched into long ellipses, yet still pulled home in the end. But imagine throwing the ball so hard that it never comes back, that it climbs beyond the grasp of gravity entirely, dwindling into the sky until it is lost. That is escape velocity. Anything exceeding it leaves forever. When the Atlas network measured the new object's trajectory, the numbers told a story no one could ignore. Its velocity was not merely high, it was too high, far too great to be held by the sun's gravity. It was moving on a hyperbolic path, a curve that would not circle back but instead slice through the solar system and depart into eternity. This was not one of ours. This was an interstellar visitor. Excitement surged. Only twice before had humanity confirmed such a traveler, first Oumuamua in 2017, then Borisov in 2019. Now, less than a decade later, a third joined their ranks. Confirmation transformed speculation into revelation. The faint firefly was no longer just a flicker in test data. It was 3I Atlas, the third identified interstellar object to pass through our cosmic neighborhood. Yet confirmation raised new questions, ones that demanded we consider categories and definitions. For in the taxonomy of celestial wanderers, labels matter. To call something an asteroid, a comet, or an interstellar object is not just semantics. It is a statement about origin, composition, and destiny. An asteroid is a body of rock or metal bound to the sun, typically dry, airless, unadorned by tails or comas. A comet, by contrast, carries volatile ices that vaporize when heated, creating luminous comas and streaming tails. Both are solar system natives, born from the same protoplanetary disk that once circled our young star. Both are kin to Earth, cousins from the family of Sol, but an interstellar object belongs to no such lineage. It is born in another system, shaped by another sun, and set adrift across the galaxy by forces we can only guess at. Its chemistry reflects foreign nurseries. Its orbit speaks of exile. To glimpse one is to hold a fragment of an alien world in our telescopes, a message written not in words, but in dust, ice, and trajectory. 3I Atlas blurred these categories in fascinating ways. It displayed comet-like activity, its coma already shimmering faintly at 6 AU, yet its speed marked it as unbound. It was comet and not comet, familiar and alien. Classification demanded nuance. To call it simply a comet would miss its exile. To call it merely interstellar would erase its behavior. It was both, a hybrid that forced us to stretch language to match reality. Astronomers began to speak of three kinds of cosmic travelers. First, the bound, those tied forever to the sun's embrace. Planets, asteroids, long-period comets that return after millennia, yet never truly escape. Second, the unbound but native, those nudged or flung away from our solar system by collisions or gravitational slingshots, destined to leave but carrying Sol's fingerprints. Third, the alien wanderers, those born beyond our skies, whose trajectories prove they come from elsewhere entirely. 3I Atlas belonged to the third. Alien, not in the sense of science fiction spacecraft, but in the deeper, older sense of the word. Other, foreign, carrying the signature of a place that is not here. The realization struck with both wonder and humility. Every calculation, every plotted curve confirmed what the velocity demanded. We were witnessing the passage of a stranger. Its orbit, when projected backward, reached into the stars, into distances beyond reckoning, suggesting a birth far from our galactic neighborhood. Its path forward would lead it past the sun and out again, never to return. We had only one chance to study it, one chance before it slipped forever into the ocean of night. By late July, papers began to circulate. Preprints spread across the astronomical community, detailing measurements, refining orbital solutions, debating classification. Press releases followed, sparking headlines across the world. The public was reminded once again that our solar system is not a sealed bubble, but a crossroad through which wanderers sometimes pass. The excitement was tangible. Schools, podcasts, and news outlets all asked the same question. What was this thing, and what could it tell us about the wider galaxy? The answer, for now, lay not in theories, but in preparation, for confirmation was only the beginning. The real work, the investigation of composition, structure, chemistry, and behavior, was just beginning. Telescopes lined up to claim time on their schedules, missions recalibrated instruments, theorists sharpened their models. The stage was set not just for classification, but for revelation. The firefly had proven itself real. The thunderstorm still raged, but now a community of watchers stood ready to follow its every flicker. The confirmations were in, the numbers written down with the authority of physics, but numbers alone cannot capture the awe of sight. It is one thing to know that a visitor has come from beyond the sun's dominion, and another to behold its shape with human eyes. Late in the summer of 2025, the first images resolved into clarity, not through the turbulence of Earth's atmosphere, but from the stillness of space itself. The Hubble Space Telescope, tireless sentinel of orbit, turned its instruments toward the faint speck. The blur sharpened into form, and in those first frames the stranger revealed a body unlike any known comet of our own system. Where one might expect a fuzzy sphere, Atlas displayed something different, a teardrop-shaped coma, elongated and asymmetrical, tapering away as if drawn out by invisible fingers of radiation and wind. In the processed images, its contours resembled a drifting organism from the depths of an ocean, a translucent body trailing filaments. Astronomers, seeking metaphors to anchor the unfamiliar, likened it to a cosmic jellyfish. Its pale glow suggested not menace, but fragility, an architecture sculpted by forces of heat and vacuum. In those shapes, there was a reminder that comets are not solid statues, but dynamic fountains, always sculpted anew by their environment. Yet the strangeness lay not only in form, but in scale. Measurements showed the coma stretching to nearly 19,000 kilometers across, a size difficult to fathom. Numbers alone dissolve into abstraction, so comparisons helped. Imagine the entire Earth, from pole to pole, sitting comfortably inside with room to spare, or the moon, our constant companion, dwarfed as though it were a marble drifting inside a cathedral. In human terms, if one were to drive a car along the diameter of Atlas's coma, even at highway speeds, the journey would take more than a week of unbroken travel. To peer at such enormity, conjured by an object whose solid nucleus was only a handful of kilometers wide, was to encounter a paradox. Smallness birthing vastness, fragility shaping immensity. The images galvanized ground-based observatories as well. In Chile, under the sharp air of the Andes, the Gemini South Observatory brought its giant mirror to bear on the traveler. Its data revealed another astonishing feature, an anti-solar tail stretching 50,000 kilometers outward, aligned away from the sun. It was not a single strand, but a diffuse fan of dust and gas, flowing like smoke under a stellar wind. 50,000 kilometers, more than 4 times the diameter of Earth. To describe such a feature as a tail seemed almost inadequate. It was closer to a river of matter, bending and streaming under the sun's constant outflow. Observers described its shape in language that straddled poetry and science. Some likened it to a kite string pulled taut by the solar breeze. Others saw the plume of a great ship's engine trailing through the cosmic sea. Yet others returned to biology, calling it the breath of an organism exhaling into space. Whatever the metaphor, the reality was clear. Atlas was alive with activity at distances where ordinary comets remain silent and inert. At 6 astronomical units from the sun, water ice is usually frozen solid, incapable of generating such plumes. Something else was powering this display, something unfamiliar. Hubble continued to watch. The coma brightened in subtle shifts, its structure quivering with solar influence. The teardrop shape wavered, as though breathing, expanding and reshaping across days. In the processed frames, faint striations hinted at jets, narrow outbursts of material erupting from the hidden nucleus. Their geometry suggested rotation, though details remained too fine to resolve. The nucleus itself stayed unseen, shrouded in the glow of gas and dust, but its influence was there, hidden in every plume and every asymmetry. For astronomers, these first glimpses were more than aesthetics, they were evidence. The sheer size of the coma and tail spoke of prodigious outgassing. To create a cloud 19,000 kilometers wide and a tail 50,000 long demanded immense quantities of material streaming away, driven by energy sources not yet understood. By comparison, typical comets of our system display comas of a few thousand kilometers when at similar distances. Atlas was not typical. It was not restrained by familiar limits. To convey the magnitude to the public, scientists turned to analogy. Imagine standing on Earth and watching the atmosphere swell until it reached halfway to the moon, they said. Imagine holding a pebble in your hand and watching it breathe out a fog the size of a continent. Imagine a mouse, tiny and frail, roaring with the power of a lion. Atlas seemed determined to defy proportionality. Its nucleus small, its presence vast, its quiet power undeniable. In classrooms and lecture halls, images were projected alongside models. Teachers explained how solar radiation and charged particles sculpt tails, how the anti-solar direction is always a compass pointing away from the star. Students stared at diagrams showing Earth compared to the expanding halo of Atlas, their faces a mixture of disbelief and awe. For many, it was their first encounter with the reality that comets are not static rocks, but ephemeral worlds, living sculptures shaped by heat and light. The metaphors proliferated because words strain under the task of description. Scientists, so often precise, spoke of beauty, of elegance, of alien grace. It is one thing to measure gas flows and particle density, another to stand before an image and feel the uncanny sense that you are seeing something not merely foreign, but fundamentally other. Atlas's architecture was not chaotic but patterned, its curves suggesting symmetry, its tail spreading in gradients that felt almost deliberate. The mind could not help but read intention into what physics alone explained. Still, the numbers grounded the wonder. Spectral analysis of the coma's glow hinted at the gases within, though full composition awaited further study. Brightness profiles confirmed the extraordinary extent. The Gemini South data, when combined with Hubble's, allowed astronomers to model the density of dust particles, revealing a consistency unlike typical solar comets. Even before the detailed chemical revelations, Atlas was showing itself as different. What struck many observers most was the contrast between delicacy and immensity. The coma, though spanning 19,000 kilometers, was tenuous, so diffuse that a human spacecraft could pass through without noticing pressure, only a faint sprinkling of dust. Yet from afar it glowed like a lantern, a gossamer veil suspended against the stars. To look upon it was to confront both scales at once, the fragility of molecules drifting in vacuum and the grandeur of a structure larger than planets. Artists began to imagine it. Renderings appeared in magazines, showing the cosmic jellyfish drifting with its shimmering halo, its pale tail arcing away. Though stylized, these images captured the sense of strangeness that even raw data conveyed. It was not only scientists who felt compelled to describe what they saw. Poets and storytellers, too, found themselves drawn into its orbit, crafting words and images to give shape to the alien visitor. Within observatories, the mood was electric. Astronomers traded preliminary results across continents, comparing notes on coma expansion rates, brightness curves, tail morphology. Each new observation sparked fresh questions. Was the nucleus spinning rapidly, causing jets to sculpt the teardrop? Was the coma asymmetry a clue to uneven surface composition? Was the massive activity powered by volatiles unfamiliar in our solar system? Each hypothesis opened doors, none yet closed by data. The visitor, for all its distance, felt close, almost intimate. It was as if the cosmos itself had offered a window into another world's geology, another system's history, written in vapor and light. The first glimpses were only the beginning, but already Atlas had shifted from abstraction to presence, from trajectory to image, from numbers to vision. It was no longer just a point on a plot. It was a body with shape, motion, and unexpected magnificence. The coma's edges blurred into darkness, the tail stretched endlessly behind, and telescopes continued to gather photons, frame by frame, building a portrait. Each observation deepened the mystery, confirming beauty while withholding explanation. The visitor, now revealed in light, stood poised for the next layer of revelation. For sight was only the surface. To truly know the alien required probing deeper into the chemistry carried within its vast exhalation. The vision of the teardrop-shaped coma still lingered when the next revelations arrived, not from images of light, but from the subtler whispers of spectrum. Where Hubble and Gemini had shown us the alien's architecture, other instruments now sought to breathe in its exhalations, to separate colors invisible to human sight into the fingerprints of elements and molecules. To see is to admire, but to measure the breath of a wanderer is to begin to understand its body. The honor of the first deep inhalation belonged to Sphere-X, NASA's all-sky spectral explorer. Its mission, still young, was to map the chemical content of the cosmos on scales from galaxies to comets. When it turned its detectors toward Atlas, it uncovered something astonishing. Around the nucleus and stretching outward was a diffuse cloud of carbon dioxide, expanding across a diameter of nearly 350,000 kilometers. Numbers can numb until translated into human scales. This cloud was not simply large, it was vast beyond ordinary reckoning. The Earth-to-Moon distance is about 384,000 kilometers. Atlas's carbon dioxide shroud nearly matched it. Imagine looking upward at the moon on a clear night, then envisioning the entire span between Earth and that glowing disk, filled with invisible vapor, a ghostly atmosphere not bound to any planet, but drifting free in interstellar space. That was the size of Atlas's exhalation. Yet size was only the beginning of the mystery. For most comets, water dominates the composition of the coma. As sunlight warms their surfaces, water ice sublimates first, carrying with it traces of carbon dioxide, carbon monoxide, and other ices in ratios that have been catalogued for decades. But when the James Webb Space Telescope trained its infrared instruments on Atlas, it reported a ratio that shocked researchers. The proportion of carbon dioxide to water was nearly 8-1. Such a figure overturned expectation. To find carbon dioxide as the majority component was not just unusual, it was unprecedented. It was as though the recipe had been inverted, a comet made not of the usual ices, but of an alien mixture. For astronomers used to seeing water dominate, Atlas was a revelation. Its breath carried the chemistry of another birthplace, one where the rules of freezing, condensation, and planetary formation diverged from our own. The Webb data did not stop with carbon dioxide. Its spectrometers teased out faint but certain signatures of carbon monoxide, CO, and carbonyl sulfide, OCS, alongside the presence of dust grains scattering sunlight. Yet across the spectrum, the expected strong absorption lines of water vapor were faint, almost absent. The alien was exhaling, but it was not exhaling the breath of a typical comet. It was whispering in a tongue our solar system rarely speaks. To the scientists parsing the results, this was more than curiosity. Chemistry is history. The ratios of molecules preserved in ice tell of the conditions in which a body formed, the temperature of its nursery, the radiation bathing its birth cloud, the elemental balance of its parent star. In this sense, comets are not merely icy bodies but time capsules. Reading their chemistry is a kind of forensic science, an autopsy of planetary formation carried out billions of years after the fact. Atlas's unusual mix forced new hypotheses. Perhaps it had formed in a region of its parent system where carbon dioxide condensed more readily than water. Perhaps it was the survivor of a disk around a faint, cooler star, one where temperatures shifted the balance of volatiles. Perhaps radiation had stripped water from its surface layers over eons in interstellar exile, leaving behind carbon-bearing ices to dominate. Each possibility pointed to different cosmic histories, different star forges, different galactic neighborhoods. For astronomers, this was the thrill and the challenge. The alien was not just beautiful, it was informative, carrying news from afar in the form of molecules. Its coma was a chemical telegram, written not by hands but by physics, shaped not by intent but by the slow processes of stellar and planetary birth. Reading that telegram required care, but each spectral line was a letter in the alphabet of the galaxy. The scale of the carbon dioxide cloud also provoked wonder. 350,000 kilometers of invisible vapor, so faint that a spacecraft could pass through it without resistance, yet so immense that entire worlds would vanish inside it. The alien's behavior was, in this sense, both logical and strange. Logical, because the physics of sublimation explained the activity. Strange, because the ratios of ice betrayed a formation history outside anything we had catalogued before. As Webb's reports circulated, excitement grew. Papers emerged rapidly, proposing models of formation around carbon-rich stars, scenarios of interstellar radiation sculpting volatile content, ideas of icy grains preserving unusual chemistry across eons. Each model was speculative, yet each underscored the same truth. Atlas was not like the comets we knew. Its very breath proved its foreignness. For the public, metaphors again bridged comprehension. Atlas was said to exhale not water, but wine, not the breath of life, but the breath of strangeness. Its chemistry was described as a dialect from another star system, a molecular accent that revealed an upbringing far from our own neighborhood. In classrooms, teachers used it to show students how molecules serve as cosmic memory, how ratios are not random but written by environment. Within observatories, the mood was one of cautious wonder. Chemists collaborated with dynamicists, theorists with observers, each trying to piece together a coherent story. Was Atlas a survivor from the outer reaches of a cold disk, expelled by planetary migration? Was it a fragment of a larger body shattered by collisions, carrying the chemistry of a mantle or core? Was the sulfur signature evidence of volcanism on a long-lost parent world? None of these could be answered yet, but each kept the story alive. The concept of forensic science resonated strongly. Astronomers began to describe themselves as detectives, lifting fingerprints from spectra, analyzing residues of an interstellar crime scene. The comet was not guilty, of course, but it was a witness, a messenger carrying evidence of processes that had unfolded far from here. Reading that evidence required patience, precision, and imagination. Each molecule was a clue, each ratio a testimony. As the data mounted, comparisons with our solar system's comets grew starker. Where ours exhale water-rich plumes, Atlas exhaled a carbonic breath. Where ours reveal familiar ratios of hydrogen and oxygen, Atlas shifted balance toward the exotic. Where ours speak of local conditions, Atlas whispered of places beyond maps. The strangeness was not threatening, but exhilarating. To see difference so clearly was to be reminded that the galaxy is diverse, that worlds form under varied laws, that our solar system is but one example among many. The coma expanded daily, its carbonic breath spreading wider, carrying the alien chemistry farther. Telescopes caught fresh readings, confirming the trends, mapping the growth. The visitor's breath filled space with strangeness, and researchers leaned closer, hoping for more secrets to surface. Atlas had spoken. Its language was not human but molecular, not symbolic but spectral. The breath of an alien world had reached us, vast and carbon-rich, carrying questions too large for quick answers. Inhaling its mystery, humanity prepared for the next revelation, for chemistry was only one layer of the enigma. The body itself, its size and power, still waited to be measured. The breath of Atlas had been measured, vast and carbon-rich, but breath alone cannot reveal the body that produces it. Behind the halo of gas and dust, behind the tails sculpted by sunlight, there lay the nucleus, the solid heart, the actual fragment of alien matter. To know its size was to confront the true scale of the paradox. How much could so little truly accomplish? The Hubble Space Telescope, once again pressed into service, set about this measurement with characteristic precision. Photometry, the art of gauging brightness, allowed astronomers to estimate the nucleus hidden within the coma. It was a difficult task. The glow of gases blurred every outline, scattering light across the field. Yet careful modeling and subtraction, comparing the diffuse halo to expectations, revealed an astonishing result. The nucleus was not large at all. In fact, its estimated diameter lay between 0.32 and 5.6 kilometers. Such numbers sound small in cosmic terms. A body barely half a kilometer across would not cover a major city on Earth. Even the upper estimate of 5.6 kilometers, though significant, would still make it smaller than the island of Manhattan. Picture that, a rock and ice fragment no larger than a city district, drifting alone through interstellar space, yet exhaling a breath the size of worlds. This was the paradox at the heart of Atlas. The metaphor most often repeated captured it perfectly. A mouse roaring like a lion. The mouse, frail, overlooked, seemingly incapable of grandeur, yet bellowing with a force that shakes the savannah. Atlas was diminutive by measure, yet ferocious in performance. Its coma dwarfed planets. Its tail stretched tens of thousands of kilometers. Its carbon dioxide cloud spanned Earth to Moon. All of this from a nucleus small enough to vanish beneath a passing cloud on Earth. For comparison, Comet Halley, the archetype known across centuries, has a nucleus about 11 kilometers long. Even with that size, Halley does not produce such extravagance at the distances where Atlas already roared. Typical comets closer to the Sun, energized by heat, show comas a few thousand kilometers across. Yet here was Atlas, farther away, colder, still inflating a veil nearly 19,000 kilometers wide. Conventional models could not stretch far enough to account for this. In lectures and journals, the paradox became a refrain. How could so small a body sustain such colossal activity? How could ices locked within a fragment only a few kilometers across power a show fit for a body many times larger? Each possibility raised further puzzles. Perhaps Atlas was unusually porous, riddled with channels and caverns that allowed gases to escape efficiently. Perhaps it contained exotic ices that vaporized with ease at great distances, releasing volumes far beyond what water could manage. Perhaps it had been fractured by collisions in its past, exposing deeper layers that exhaled in cascades. None of these, however, fully resolved the paradox. The models of comets used for decades rested on assumptions shaped by our solar system. Water as the driver of activity, surface layers as regulators of gas release, gradual warming leading to predictable outgassing. But Atlas seemed to shrug off those expectations. It was not gradual but exuberant, not restrained but excessive, not water-driven but carbon-fed. It roared before the warmth of the inner system had even touched it. Some speculated that its small size was deceptive. Perhaps the nucleus fell toward the upper end of the estimates, closer to 5 kilometers, its geometry allowing for unusually high activity. Yet even then, the ratios remained extreme. Others suggested that interstellar travel had altered its structure. Perhaps cosmic rays had transformed its surface chemistry over eons, creating layers that erupted when touched by even faint sunlight. The paradox deepened the longer one looked. Visualizations circulated in conferences, comparing Atlas to familiar bodies. An image of Manhattan was overlaid with the scale of its nucleus. The comparison looked almost laughable. A city block-sized wanderer producing a presence bigger than planets. Another chart placed Atlas against Mount Everest, showing that the mountain would tower over its likely dimensions. How then could such a fragment sculpt tales measured in tens of thousands of kilometers? The analogies did not resolve the question, but emphasized the wonder. The paradox also raised existential questions for comet science itself. If Atlas could be so small and yet so active, how many assumptions about cometary physics required revision? Were our models too Earth-centric, too shaped by water's dominance in our own system? Perhaps in other stellar nurseries, different volatiles dominate, rewriting the behavior of small icy bodies. If so, then Atlas was not an outlier, but a messenger from a larger truth, that comets across the galaxy come in more varied forms than we had dared to imagine. The notion of sustained activity far from any star carried implications beyond Atlas itself. In our solar system, comets typically wake as they approach Jupiter's orbit, sunlight strong enough to thaw water and drive tails. But Atlas had awakened already at 6 AU, sustained by forces not yet fully understood. This suggested that interstellar space might contain many such bodies, glowing faintly with carbon dioxide and carbon monoxide even in the darkness between stars. They might drift with comas invisible to the naked eye, subtle lanterns marking their passage. If so, then Atlas was not only unique but also representative of an unseen population. Astronomers wrestled with the thought. For decades, comets were considered icy relics, fragile archives of their home systems. Now one such relic defied its label, teaching that even the small can perform like the great, that even the faint can blaze across the sky. The paradox shook more than theories. It unsettled assumptions about what matter can do when freed from the familiar warmth of the sun. The mouse-lion analogy spread beyond science. Newspapers used it in headlines. Documentaries latched onto it for narration. The public grasped at the image of a tiny body roaring across the cosmos. It became shorthand for the paradox itself, a way to communicate that size does not always dictate power. The visitor embodied that truth more vividly than any metaphor alone could manage. Behind the scenes, researchers pushed their instruments further. Brightness curves were measured across wavelengths, refined estimates of albedo calculated, models of dust production tested against observations. Still, the numbers refused to reconcile with conventional expectations. Atlas was small, Atlas was powerful. Both statements were true, yet together they strained comprehension. In coffee rooms at observatories, conversations turned speculative. Could Atlas represent a new class of interstellar objects? Might it be a fragment from a disrupted larger body, its internal chemistry exaggerated by the violence of separation? Was it possible that exotic physics, supervolatiles unknown in our system, were at play? Though speculation wandered wide, the sense of humility remained. The paradox had not been solved, but it had been revealed. That was enough to spark the next wave of inquiry. The nucleus, hidden beneath its breath, remained elusive to direct imaging. Hubble's numbers were estimates, not photographs. No telescope yet resolved the solid body itself. It was still a mystery wrapped in light, a secret at the heart of a storm. Yet in that secrecy lay power. The power to force humanity to question its understanding of ice, rock, and the physics of small bodies. Atlas had already achieved something remarkable. It had reminded us that the universe is under no obligation to conform to our models. So the paradox persisted, tantalizing, unresolved. The mouse roared, the lion whispered in its shadow, and astronomers prepared to look deeper still. For if size and activity could mislead, perhaps composition at the elemental level could offer clarity. Somewhere in the spectra, in the metals and minerals, there might be fingerprints of the alien star where Atlas was born. The paradox of size and power had unsettled expectations. Yet within the glow of Atlas, another layer of strangeness waited to be uncovered. If its body could defy the rules of scale, perhaps its chemistry could defy the rules of origin. To pierce the veil further, astronomers turned to the most powerful tools of elemental forensics: spectroscopy, the practice of reading light as if it were a written language. In Chile's Atacama Desert, where dry air sharpens the view of the heavens, the European Southern Observatory's very large telescope was tasked with this investigation. Each of its giant mirrors collected the scattered photons pouring from Atlas's coma, spreading them into spectra. Rainbows stretched thin until their dark lines appeared. Those lines, fingerprints of atoms, revealed which elements glowed within the cloud. The expectation was simple. The familiar signatures of cometary matter, echoes of oxygen, carbon, hydrogen, with metals like iron lurking in faint abundance. What appeared, however, was anything but ordinary. Among the signals lay a set of lines belonging to nickel. This alone was surprising, for nickel, though present in comets, usually appears paired with its close cousin iron. They are born together in the furnaces of stars, forged under similar nuclear conditions, and distributed in tandem across cosmic dust. To see nickel without iron was like hearing only half of a duet, one voice singing in absence of the other. The spectrum's silence where iron should have spoken was deafening. The astonishment spread quickly. Nickel lines shone clearly, undeniable, but iron remained hidden, its expected features absent or vanishingly faint. For researchers trained on the periodicities of our solar system, this was a discordant note. Why would a body show nickel's voice without iron's harmony? What kind of stellar nursery would produce such an imbalance? The significance of this discovery could not be overstated. In our own solar system, metals such as nickel and iron appear in nearly constant ratios, a reflection of their joint creation in stellar cores and supernova. Their companionship is so reliable that to encounter nickel alone is to encounter evidence of a birthplace governed by unfamiliar rules. Atlas, in its glowing veil, was carrying more than dust and gas. It was carrying a story of stellar chemistry, a dispatch from the nursery that birthed it billions of years ago. Here, the periodic table ceased to be a classroom chart and became instead a cosmic birth certificate. Each element in Atlas's spectrum was a signature written at its origin, a coded message from the environment where it condensed. The missing iron was not simply an omission, it was a revelation of difference, an announcement that this body was not merely foreign in trajectory but foreign in essence. To make sense of it, astronomers revisited the processes of stellar alchemy. In massive stars, layers of fusion produce elements in predictable sequences, hydrogen to helium, helium to carbon and oxygen, and eventually heavier metals such as silicon, nickel, and iron. When such stars die in supernovae, these elements are cast into surrounding space, seeding future planets, comets, and atmospheres. The recipes vary with the mass of the star, the violence of its death, and the mixing of its layers, but some ingredients are nearly universal. Nickel and iron, siblings at birth, normally travel together. For Atlas to carry nickel without its twin suggested that the supernova, or supernova, that enriched its nursery had followed an unusual path. Perhaps conditions favored nickel's survival while suppressing iron. Perhaps dust condensation in that system filtered one element more efficiently than the other. Or perhaps Atlas formed in a region where stellar explosions were uneven, scattering unusual proportions into the molecular cloud. Whatever the mechanism, the implication was clear. The cradle of Atlas had a chemistry unlike that of our solar neighborhood. This realization struck a chord with those who saw comets as couriers. Atlas was not merely a visitor drifting through by chance. It was a messenger carrying news from a distant star system. Its light carried the accent of its home, a dialect of the periodic table that diverged from our own. By studying that accent, humanity could glimpse environments never otherwise reachable. No telescope could yet map the dust of its nursery, but Atlas carried a sample directly across interstellar space, delivering it into our instruments. Speculation flourished. If nickel without iron defined Atlas, what else might its spectrum reveal? Could it carry ratios of carbon to oxygen unseen in our system, whispering of planets formed with exotic atmospheres? Could it preserve noble gases, trapped in ices forged under alien conditions? Every additional observation became a chance to broaden the picture of its birthplace. Each line in the spectrum was a sentence in a story written across eons. The metaphor of the periodic table as a birth certificate spread quickly. Just as ink on paper certifies the time and place of human arrival, the elemental lines in Atlas's spectrum certified the environment of its cosmic birth. Unlike a human document, however, this one had traveled for perhaps millions of years, untouched, sealed within frozen matter until sunlight teased it out in a distant system. To read it was to open a time capsule carried faithfully across the galaxy. The question of the missing iron provoked deep discussion. Was it truly absent or simply hidden, its lines obscured by other emissions? Detailed modeling leaned toward true scarcity. Nickel appeared robust, unmistakable, while iron lines, if present, fell below detection thresholds. The ratio was skewed beyond what ordinary cometry physics could explain. In the silence of iron's absence, astronomers heard the voice of another galaxy's story, one that refused to harmonize with ours. Such differences mattered profoundly. Elements dictate the architecture of worlds. Iron forms the cores of planets, drives magnetic fields, shapes geology. A system deficient in iron yet rich in nickel might produce planets with unfamiliar compositions, atmospheres lacking the familiar balances, even biospheres that evolve under altered chemistry. Atlas's spectrum was thus not only about itself, but about the possible architectures of alien worlds. In the faint glow of its coma lay the hint of landscapes that might never be seen yet could be imagined. Mountains built of unusual alloys, oceans flavored by different balances of salts, skies tinted by metallic traces unlike any on Earth. For the astronomical community, this was both exhilarating and humbling. Atlas was small, fragile, easily dismissed as another wandering speck. Yet in its chemistry, it carried the grandeur of distant stars. Its nickel lines spoke louder than its size, louder than its tales. They reminded us that every interstellar visitor is a library, every spectrum a volume waiting to be read. The paradox of its body now joined the enigma of its elements, each deepening the sense that this was no ordinary traveler. The discovery also emphasized how much the universe still resists simplification. Decades of comet study had suggested reliable patterns, categories, and ratios. Atlas unsettled those patterns, not in noise or error, but in clarity. Bright nickel, quiet iron, an imbalance impossible to ignore. It forced the periodic table itself to become a narrative, a reminder that universal laws manifest in diverse local variations. The fingerprints of Atlas invited a new kind of imagination. If each comet carries the accent of its nursery, then every interstellar visitor is a fragment of cosmic diversity. 1I Oumuamua, 2I Borisov, and now 3I Atlas, each bearing not only orbital strangeness but chemical signatures hinting at alien histories. Together they form the beginnings of a comparative study of other star systems, written not in photographs but in spectral lines. The more that arrive, the more complete the atlas of chemical dialects becomes. In quiet moments, astronomers lingered on the poetry of it. Light, broken into rainbows, revealed secrets of stars long dead, secrets preserved in a fragment smaller than a city. That fragment drifted for perhaps 1 billion years, untouched by suns, until captured briefly by our awareness. Nickel lines, faint and unwavering, became a conversation across the galaxy, a reminder that the universe is both stranger and more intimate than we imagine. Atlas had spoken its elemental truth. Yet as with every revelation, the discovery raised more questions than it answered. What else lay hidden in its spectrum, waiting for longer exposures and sharper instruments? What could these fingerprints teach us not only about where Atlas was born, but about how matter itself evolves across the galaxy? Could the absence of iron be a clue not to a single nursery but to an entire region, a galactic neighborhood with chemistry distinct from our own? The roar of the mouse had become a whisper of metals, subtle yet profound. Atlas had given us its fingerprints, pressed into light, left for us to decipher. But fingerprints are only the beginning. Behind them lie identities, lineages, histories yet to be traced. The visitor still carried secrets, waiting to be unfolded as it approached nearer to the sun, where heat might release even more signatures into the spectra. The investigation would continue, for Atlas had not yet revealed the whole of its message. The fingerprints of Atlas shimmered like a riddle in light, but its journey was only just beginning to intertwine with our own. Having revealed hints of its alien origin, the interstellar traveler now prepared to step into a new role, not simply a messenger of chemistry, but a performer in the vast choreography of orbital mechanics. Space itself was the stage, planets the partners, and on October 3rd, 2025, the first movement of this cosmic dance would take place beside Mars. That date was marked with a quiet sense of anticipation, for while Earth would not see its closest encounter with Atlas until months later, it was Mars that would be first to greet the visitor in proximity. At a distance of 18 million miles, still vast by human standards, yet close by astronomical measure, the red planet would become the opening act in the grand tour. It was not by design that Atlas should pass Mars first, but by the impartial mathematics of trajectory. Gravity bends paths like a river curving around a mountain, and Mars happened to lie directly along the course. To many, this encounter seemed symbolic. Mars, the planet of exploration, where human eyes and machines have long searched for signs of life, would also be the first to witness the arrival of a body carrying secrets from another star. In the dry silence of its deserts, under skies thin with carbon dioxide, robotic sentinels would turn their gaze upward to study Atlas as it passed. 2 spacecraft were already perfectly poised for the task: NASA's MAVEN mission and China's Tianwen-1 orbiter, both designed to study the Martian atmosphere and geology, now found themselves in the role of interstellar observers. Their instruments, tuned to measure gases and particles, could detect the faint whispers of dust and plasma streaming from Atlas as it brushed past. What was meant to be a planetary science fleet had, by fortune and foresight, become part of a solar system-wide observatory. The logistics of this coordination were staggering. Scientists on Earth calculated precise alignments, timing the spacecraft's instruments to coincide with Atlas's trajectory. Communication delays, up to 20 minutes between Mars and Earth, meant there would be no room for improvisation. The spacecraft had to operate on preloaded sequences, like musicians given sheet music long before the performance began. When October 3rd had arrived, they would play their parts without guidance, collecting data silently as the visitor swept by. The image of orbital mechanics as a dance is more than metaphor. To understand Atlas's path, astronomers described it in the language of ellipses, inclinations, and eccentricities. Yet beneath the mathematics lay a deep poetry. Every motion was governed by gravity's patient hand, every curve a response to invisible attraction. The flyby at Mars was not random. It was written the moment Atlas crossed the boundary of our solar system. Its speed, its angle, its direction relative to the ecliptic, all combined to dictate this rendezvous. Mars did not choose to be first, nor did Atlas choose to honor it. The laws of motion chose for them, binding planet and traveler in a temporary geometry. Still, the symbolism was irresistible. Mars, long a mirror for human curiosity, would now reflect the gaze outward toward a guest from beyond. Instruments that once measured the escape of carbon dioxide from Martian skies would now sample the exhalations of a cometary coma. Radar designed to probe dust storms would listen for alien grains striking sensors. MAVEN and Tianwen-1, born of human ambition to know a neighboring world, would extend that ambition farther, outward to the interstellar night. The choice of Mars as the first vantage point also offered practical advantages. From Earth, Atlas was still distant, its light faint, blurred by the atmosphere of our planet. But from Mars, with its thinner air and smaller gravitational distractions, spacecraft enjoyed a clearer window. The geometry of orbits meant Mars would intercept Atlas's line of sight earlier than Earth could, providing an advance look, like scouts glimpsing the arrival of an envoy before it reached the capital. 18 million miles may sound unfathomable, but in cosmic terms it is an intimate brush. Consider that Earth lies 93 million miles from the Sun. By comparison, Atlas would pass Mars at less than 1/5 that distance. For spacecraft orbiting Mars, the passage was close enough to resolve details invisible to Earth-bound telescopes. Dust tails, particle streams, and magnetic interactions all could be studied with clarity impossible from our vantage point. The data from this flyby promised to enrich more than cometary science. By observing how Atlas interacted with the solar wind at Mars's distance, scientists could compare it with measurements at Earth later in the year. This would allow a rare experiment, studying the same interstellar object under different solar conditions, like watching a traveler adapt to changing climates. Mars provided the prologue, Earth the central act, and beyond awaited the finale with Jupiter. The grand tour was unfolding step by step. Behind every calculation lay an undercurrent of awe. To think that an object born in another star system, wandering through the void for eons, should by chance pass within range of our instruments at Mars, was staggering. The odds defied imagination, yet orbital mechanics, indifferent to wonder, made it inevitable once the path was measured. What appeared miraculous was, at its core, the consequence of precision, gravity guiding motion across scales we rarely contemplate. This sense of inevitability is what drew astronomers to describe orbital mechanics as a kind of cosmic choreography. Every planet, every comet, every spacecraft all move in steps dictated by the same invisible music. The rhythms are slow, vast, beyond human perception, yet they are as reliable as any clock. Atlas had joined the dance, weaving temporarily among the planets before continuing on its way. To watch was to witness not just a discovery, but a performance scripted billions of years ago. Expectations were carefully managed. Scientists knew that Maven and Tianwen-1 were not designed for this exact purpose. Their instruments lacked the specialization of observatories like JWST or Hubble, yet their vantage point was priceless. Even imperfect data, gathered at close range, could reveal structures in Atlas's tail or compositions in its dust that telescopes on Earth might miss. The encounter was an opportunity not to be wasted, a chance to stretch technology beyond its intended limits. The preparations extended beyond Mars. Teams on Earth synchronized their own observations, ensuring that telescopes from Chile to Hawaii were watching at the same time. The goal was to weave together a full picture, combining distant Earth-based views with the intimate glimpses from Mars orbit. This required coordination across nations, agencies, and disciplines. In that sense, Atlas was already achieving something rare, uniting global efforts in a shared act of wonder. As the date approached, anticipation deepened. Visualizations traced Atlas's path across simulated skies, showing the precise geometry of the flyby. Models predicted how its coma might flare under solar wind pressure, how its tail might bend, how particles might stream into Mars's magnetosphere. Every forecast carried uncertainty, but that uncertainty only heightened the excitement. The unknown was the very essence of the visitor's gift. When October 3rd arrived, Mars would not speak in words but in data streams. Binary code would trickle back to Earth, carrying the signatures of an alien body brushing past a neighboring world. Behind each number, behind each spectrum and particle count, lay a glimpse of the grand story, a traveler from another sun, crossing paths with the planet we have long considered our second home. The poetry of the encounter was undeniable. The stage was set. Mars had claimed the first close look, a role assigned not by human choice, but by the impartial script of the cosmos. Maven and Tianwen-1 were ready to play their parts, orbiting above red deserts that had waited eons for such a performance. The flyby would not answer every question, but it would deepen the mystery, laying groundwork for what came next as Atlas pressed onward, toward the inner system, toward the sun itself, where heat and light would demand another transformation. The Martian flyby had marked the first movement of the grand tour, yet all who followed Atlas knew the true crescendo would come when the visitor drew near to the sun itself. Every cometary path carries this moment of trial, the instant when icy shells confront the blaze of a star, when fragility meets overwhelming force. For Atlas, that day was written into its trajectory. October 29, 2025, when it would pass perihelion at a distance of 1.36 astronomical units from the Sun, closer than Mars yet still outside Earth's orbit. This was the point where its speed and activity would peak, where its very substance would be rewritten by heat. As the date approached, models predicted a velocity nearing 152,000 miles per hour. This figure stunned even seasoned astronomers. Nothing humanity had built, not spacecraft, not probes, not even the fastest interplanetary trajectories, had ever reached such speeds relative to the Sun. Atlas would be moving faster than anything human-made, a needle of ice and dust tearing through the fabric of the inner solar system with furious momentum. The sheer number, 152,000, carried both thrill and dread. To watch such a traveler was to be reminded of the limits of our reach, of how small and slow our machines truly were. Yet the irony of perihelion was this: though Atlas blazed brighter and flew faster than ever, Earth would be unable to see it. The geometry of orbits placed the comet close to the sun's glare from our perspective, hidden in what astronomers sometimes call the cosmic blind spot. To look toward Atlas was to look toward the star itself, a brightness so overwhelming that even the most advanced instruments on Earth were dazzled into blindness. At the very moment Atlas revealed its greatest transformation, it also concealed itself behind the veil of the sun's radiance. This paradox gave the encounter a mythic tone. The sun was both revealer and concealer, burning away ice to release new tails and vapors, yet blinding observers who sought to witness the spectacle. In ancient times, comets were seen as messengers of gods, often appearing near the sun in twilight skies, too bright for ordinary stars to compete. Atlas carried that aura into modern science, a body undergoing metamorphosis at the heart of light, unreachable to direct human eyes. Still, astronomy has ways of peering into blindness. Spacecraft designed to monitor solar weather, such as NASA's Solar and Heliospheric Observatory, SOHO, and the twin stereo probes, were positioned to watch from angles Earth could not. Their coronagraphs, instruments built to block out the sun's disk, could reveal faint structures in the surrounding corona. Through these artificial eclipses, Atlas might be glimpsed in silhouette, a glowing veil swept outward by solar wind. While Earth turned its eyes away, these guardians of heliophysics prepared to bear witness. The transformation itself was expected to be dramatic. At 6 astronomical units, where Atlas was first spotted, the cold of space preserved its ices in relative stillness. But at 136 AU, sunlight poured in with 20 times the intensity, driving temperatures to levels that water ice could not resist. Layers buried for billions of years would begin to sublimate, releasing hidden compounds into the coma. Jets would roar from fissures, plumes would expand, the body itself could fracture under the stress. Every comet that braves perihelion undergoes this ordeal, but Atlas, already paradoxical in size and chemistry, promised surprises. Astronomers described the moment as a dialogue between ice and fire, molecules locked in crystalline prisons since the dawn of another star system now met photons streaming from our own. The encounter was both destructive and revelatory. Each grain of dust released, each molecule of carbon dioxide or carbon monoxide became a messenger, carrying information about conditions that predated our sun. To watch Atlas shed material was to watch time itself unravel, a story told in vapor. The metaphor of metamorphosis dominated the imagination. Atlas was compared to a moth flying too near the flame, its wings igniting in a brief flare of glory. It was likened to a traveler shedding cloaks under the desert sun, revealing layers hidden beneath. Some spoke of it as a chrysalis, cracking open under heat to show what had been locked within. Scientific models reduced the process to equations of sublimation rates and energy balances, but the imagery could not be ignored. Here, in the blinding presence of the sun, Atlas was transformed into something both less and more than it had been. Less in mass, more in revelation. This period also highlighted the precariousness of comets. Many do not survive their perihelion passages. Tidal stresses, volatile eruptions, or simple fragmentation can shatter them into streams of dust. The famous sun grazers of history have ended their lives in spectacular disintegration, scattering tails that stretch across twilight skies before fading. Would Atlas endure its passage, or would it scatter into fragments, its story ending in a glittering dissolution? The question hung in every calculation, adding suspense to the already blinding trial. Despite the sun's glare, expectations were not empty. Ground-based observatories planned to catch glimpses in twilight windows, using specialized filters to separate cometary emissions from solar haze. Instruments tuned to carbon dioxide and oxygen lines prepared to detect bursts of activity even through partial obstruction. The Very Large Telescope, JWST, and other giants would bide their time, ready to resume once Atlas emerged from conjunction. But until then, heliophysics missions carried the burden of observation. The timing of the passage also gave it resonance. October 29th marked the turning of Earth's seasons, a moment when northern skies grew longer and darker. Across much of the world, the sun dipped lower each day, yet for Atlas the sun loomed larger than ever. The contrast deepened the sense of drama. While Earth entered shadow, the visitor entered blaze. It was a cosmic reminder that every vantage point tells a different story. Every orbit frames the universe uniquely. The speed itself demanded contemplation. 152,000 miles per hour, more than 40 miles each second, was a number almost beyond comprehension. Visualization struggled to convey it. To travel from New York to Los Angeles at such speed would take less than a minute. To circle Earth's equator would take under 40 minutes. Yet Atlas sustained that velocity effortlessly, propelled not by engines but by the gravity of the sun, the same force that binds our world to its orbit. Motion on that scale humbled the imagination. Some scientists framed the moment as a kind of cosmic interrogation. The sun, in its fury, forced Atlas to reveal its secrets, stripping away protective shells and exposing its chemistry. Like an ancient scribe revealing hidden ink under fire, the star's radiation illuminated what had been invisible. But the sun was also a jealous interrogator, hiding the process from distant observers. What was revealed in physics was concealed in sight, a contradiction that mirrored the dual nature of light itself. Speculation lingered about what new compounds might emerge. Earlier chapters of Atlas's journey had revealed carbon dioxide in strange proportions, nickel without iron, activity far beyond expectation. Perihelion promised to amplify these mysteries. Would exotic organics be released? Molecules complex enough to hint at prebiotic chemistry? Would the nucleus fracture to expose fresh surfaces, altering its spectral voice yet again? The questions swirled, unanswered, suspended until data could return from the hidden encounter. For astronomers, this moment carried a mixture of frustration and wonder. To know that transformation was unfolding so close, yet to be barred from direct sight, was an agony akin to hearing a symphony muffled through walls. Still, the knowledge that spacecraft were listening from vantage points we could not reach offered consolation. Through them, humanity extended its senses, bridging blindness with ingenuity. The sun could not entirely conceal what it revealed. Atlas's journey through perihelion was no mere technical milestone. It was a ritual as old as the solar system, a trial by fire repeated countless times by icy bodies falling inward. Yet this time the body came not from our system but from another, its chemistry and structure already defying expectations. Perihelion was the crucible in which those mysteries would either clarify or deepen. Ice met stellar fury, and in that confrontation lay the potential for revelation. But perihelion was not the end. It was the midpoint of the journey through the inner system. Beyond lay Earth's turn, when telescopes would again have the advantage, when instruments like JWST and Rubin could capture details unblurred by solar brilliance. After perihelion, Atlas would re-emerge from the glare, changed, reshaped, bearing the marks of its passage. The anticipation of that reappearance grew with every calculation, every model, every speculation. For now, however, all eyes turned toward the sun, knowing that within its glory, Atlas was being remade, hidden yet luminous, fragile yet defiant. The story of the interstellar traveler was only half told, its most intimate chapter still veiled. Atlas emerged from the solar glare altered but unbroken, carrying the marks of its perihelion passage like scars on a traveler returned from a furnace. As it swung outward along its hyperbolic trajectory, one date rose above all others in anticipation: December 19th, 2025. On that day, the alien wanderer would pass at its minimum distance from Earth, 170 million miles away. Farther than Mars, closer than Jupiter, the gap was vast, yet in cosmic terms, it was intimacy. Humanity would never stand nearer to this interstellar visitor than in that moment. The phrase "closest approach" undersells the gravity of such an alignment. For planetary astronomers, this was the single best window to unlock Atlas's deepest secrets. The geometry of orbits had conspired to place Earth in just the right vantage, far enough from the solar glare that had hidden the comet weeks before, yet close enough to bring its faintest emissions within reach of the most sensitive instruments ever built. Telescopes across the globe prepared for their turn, but two giants stood at the forefront of this observational campaign: the James Webb Space Telescope and the Vera C. Rubin Observatory. High above the warmth of Earth's atmosphere, JWST prepared to unfold its golden eyes toward the traveler. Its infrared spectrographs, designed to see the faintest heat from the earliest galaxies, would now be turned inward to a mere interstellar shard. For scientists, The irony was exquisite. The same tool that studied galaxies billions of light years away would also reveal the molecular breadth of an object only 170 million miles distant. Infrared light would pierce the veils of dust, mapping the volatile chemistry Atlas exhaled after its trial near the Sun. Ratios of carbon dioxide, carbon monoxide, organics, and water vapor could be traced with unprecedented precision. JWST promised not just glimpses but forensic autopsies of alien ices. On the ground, the Vera Rubin Observatory, still fresh in its mission, offered another gift. Its wide-field survey capabilities could capture the evolving structure of Atlas's vast coma and tail. Where JWST delivered intimacy, Rubin delivered context, charting the scale and dynamics of dust streams tens of millions of miles across. With exposures taken night after night, it would weave a time-lapse tapestry of Atlas's behavior, recording how jets flickered, how tails shifted, how the visitor's architecture writhed under solar wind. In tandem, the two observatories formed a dual vision, one peering into the smallest details, the other capturing the grand design. Astronomers described the encounter as a cosmic interrogation under floodlights. The Earth's instruments were aligned, the geometry optimal, the opportunity fleeting. For weeks around December 19th, humanity would have its clearest view. After that, Atlas would recede, growing fainter with each passing month, until even the greatest telescopes could only guess at its presence. The race against time was palpable. Every observation was a question asked of the universe. Every photon captured a fragile answer before silence reclaimed the traveler. The sense of urgency intensified with the knowledge of what lay ahead. Beyond Earth's vantage, another planetary encounter loomed. March 16, 2026, when Atlas would sweep past Jupiter at a distance close enough for the Juno spacecraft to attempt something extraordinary. Unlike telescopes bound to light, Juno could sample the dust environment directly, catching grains of matter shed from the interstellar body. For the first time, particles forged in another star system might be physically touched by a human-made probe. The possibility electrified the community. If successful, it would be nothing less than holding a fragment of an alien world in our grasp. Yet the timing was cruel. Juno, designed for orbital studies of Jupiter's magnetosphere, was nearing the end of its mission life. Its instruments were not tailored for cometary dust collection. Engineers debated what modifications could be attempted, how sensitive instruments could be tuned to detect impacts of tiny grains. Every calculation became a wager. Could a spacecraft conceived for one mission adapt to seize a once-in-a-civilization chance? The answer was uncertain, but the attempt would be made. The hope of tasting the dust of Atlas burned too brightly to be ignored. Between December's closest Earth approach and March's Jupiter flyby stretched a liminal space, months in which Atlas would drift steadily farther, yet still within range of the great observatories. The period was likened to the last conversations with a departing guest, when questions are asked in rapid succession because the door is already open and departure imminent. Each night of data, each spectrum recorded, carried the weight of finality. Astronomers knew this was not like waiting for a comet to return. Atlas was unbound, on a hyperbolic course, destined never to orbit back. When it vanished into interstellar night, it would be gone forever. The emotional dimension of this awareness could not be ignored. Science is often framed as clinical, dispassionate, yet here the tone of the community shifted. To study Atlas was to stand in the presence of a traveler who had crossed the gulfs between stars. To lose it was to watch that presence recede beyond reach, carrying mysteries unsolved. The urgency to gather data was matched by a quiet melancholy, the recognition that this was a fleeting brush with eternity. Technical preparations reflected this urgency. JWST scheduled long observation windows, balancing the needs of exoplanet studies with the rare priority of an interstellar object. Rubin calibrated its survey cadence to catch Atlas at optimal altitudes above the horizon. Other observatories joined in, ALMA to study submillimeter emissions, Hubble to continue visible light monitoring, even amateur astronomers with backyard telescopes, hoping for a glimpse of a faint smear against winter skies. The collaboration felt global, united by the recognition that this was not just another comet. This was a story written beyond Earth, a story that Earth had only briefly been invited to read. The numbers themselves gave perspective. At 170 million miles, light took just over 15 minutes to travel from Atlas to Earth. That meant every image, every spectrum, was already a quarter of an hour old by the time it reached our screens. Yet against the backdrop of interstellar distances, that delay was nothing. Compared to the millions of years Atlas had spent wandering between stars, 15 minutes was instantaneous, almost intimate. The paradox of distance and closeness framed the encounter, impossibly far to the human body, achingly near to the cosmic imagination. As December 19th approached, anticipation reached fever pitch. Papers were drafted in advance, filled with placeholders waiting for numbers. Conferences scheduled special sessions, expecting to update slides with fresh results on the spot. Students prepared to work sleepless nights, reducing data as it arrived, knowing their careers might be defined by the findings. For all the tension, there was also joy. The joy of living at a moment when the universe had sent a messenger our way, when technology had matured just enough to listen, when curiosity had aligned with opportunity. Then came the reminder that Atlas's path was not pausing for our convenience. The object hurtled forward relentlessly, its speed unyielding, its trajectory indifferent. It was humanity that raced, not Atlas. We scrambled to gather what we could before distance and darkness reclaimed it. The metaphor that spread among astronomers was simple: a firefly passing a porch light. The glow was brief, the vision fleeting, but those who noticed would never forget. December 19th was not the end of the story. Jupiter still waited, a second stage of intimacy, a final chance for in situ interaction. But the Earth encounter was the climax of remote study, the moment when all instruments on and around our planet converged in unity. Afterward, as Atlas pulled away, each observation would become fainter, each return diminishing. The visitor would slip back into the larger silence of interstellar night, leaving us with only the data, the memories, the unanswered questions. For now, though, the attention of the world turned skyward, to the faint point of light crossing the deep dark, knowing this was the closest we would ever be. The firefly had passed the porch light, but the glow it left behind stirred questions that burned hotter than any flame. Astronomers could catalogue trajectories, measure velocities, analyze spectra, and publish reams of data, yet beneath the rigor of numbers rose a tide of speculation. Atlas was more than just an object. Its presence was an invitation to wonder. The very fact that something forged in another star system had wandered so close forced humanity to ask not only how it came to be, but also why it carried the particular fingerprints it did. Some questions belonged to mathematics, others belonged to imagination. One of the most outspoken voices willing to cross that line was Avi Loeb of Harvard University. Known for challenging orthodoxies, Loeb had already made waves by suggesting that the first known interstellar visitor, Oumuamua, might have been more than a natural rock. With Atlas, he found new material for provocation. Could the peculiar activity, the anomalous chemistry, the sheer improbability of its trajectory be interpreted as evidence not of randomness, but of intention? Loeb proposed the possibility, deliberately couched as hypothesis rather than conclusion, that Atlas might function as a kind of beacon or probe sent across the gulfs to signal presence. The idea was not that it glowed with radio transmissions or bore inscriptions, but that its very survival, its unusual composition, and its passage through the inner solar system might be part of a message written in physics rather than language. Most astronomers rolled their eyes. The culture of science demands skepticism, and extraordinary claims require extraordinary evidence. Yet even the critics admitted that Loeb's provocations served a useful role. They forced the community to examine its assumptions, to consider explanations outside the narrow box of conventional models. If nothing else, the beacon hypothesis sharpened the focus on what exactly distinguished Atlas from the comets we knew. Why did it act as though it contained more energy than its size suggested? Why did it breathe carbon dioxide so freely, yet seem so stingy with water? Why did it carry nickel without iron, a ratio so alien to the solar recipes we expected? If natural explanations could suffice, they would need to be as strange as the artificial one. The strangeness deepened when astronomers returned to a detail that had hovered since discovery. Atlas emerged from the direction of Sagittarius, the galactic center, the same region where the enigmatic WOW signal of 1977 had been traced. Was this simply geometry, coincidence born of random trajectories intersecting with our system? Or was there some deeper significance to the repeated alignment of mystery with that stellar heart? The temptation to see design lurked everywhere. To poets and dreamers, it seemed almost scripted, signals and visitors arriving from the same celestial neighborhood, as though the galaxy itself whispered from its core. To scientists, the alignment had to be tested against probability. After all, the galactic center spans a large portion of sky, and statistically, many incoming interstellar paths might overlap with it. Still, the resonance was difficult to ignore, the echo of 1977 reverberating across nearly half a century to meet 2025. What was beyond dispute was the antiquity of the traveler. Based on velocity, trajectory, and compositional clues, Atlas almost certainly formed long before our own solar system was born. Some estimates placed its age at over 5 billion years, perhaps drifting through interstellar darkness, while the sun itself was still coalescing from a molecular cloud. If so, Atlas was not just older than Earth, it was older than Earth's possibility. The dust on its surface, the ices in its interior, could predate every mountain, every ocean, every living cell that would one day crawl upon our planet. To study Atlas was to handle the relic of a history deeper than human imagination, a shard of creation flung across time. Yet how does such a fragile thing survive such stretches? Interstellar space is no gentle cradle. It is filled with radiation, with the faint bombardment of cosmic rays, with encounters near passing stars. Many fragments are pulverized, dissolved, or captured long before billions of years tick past. Atlas somehow had endured. Perhaps its small size helped, reducing the chances of catastrophic collision. Perhaps its chemical composition granted resilience, its carbon dioxide and nickel shielding it from processes that erode ordinary comets. Or perhaps survival was simply a game of vast numbers, trillions of bodies flung from trillions of systems, with only a lucky few persisting to wander still. In that lottery of endurance, Atlas happened to draw the ticket that brought it to us. Yet luck does not fully satisfy the human spirit. The mind reaches for meaning. If survival was improbable, could improbability itself suggest intention? Was Atlas guided, nudged, shepherded by forces we do not understand? Theories ranged wildly. Some saw in its endurance a hint of artificial preservation, as though it had been engineered to last. Others proposed more subtle natural mechanisms, regions of interstellar medium sparse enough to offer protection, galactic orbits that avoided crowded stellar neighborhoods, shielding by larger companions we never detected. Between deliberate design and blind chance stretched a spectrum of explanations, each demanding its own evidence. This spectrum, from the mundane to the magnificent, defined the debates that swirled around Atlas. On one end stood those who argued it was nothing more than a peculiar comet, a statistical outlier among interstellar debris. To them, its chemistry and activity could eventually be reconciled with models once enough data were gathered. On the other end stood those willing to consider that Atlas might be the first artifact we had ever encountered, not just matter from another system, but matter with a purpose. Between those poles lay intermediate visions, Atlas as a relic of a different kind of stellar nursery, a fragment of a planetary disk around a star unlike the sun, a survivor of processes alien yet natural. What gave these speculations weight was not just data, but also history. Humanity has a long tradition of encountering the unknown and projecting meaning upon it. From ancient comets seen as omens to modern radio bursts debated as signals, the pattern repeats. Mystery invites story. With Atlas, the stories gained a sharper edge because the object was literally here, within sight, within reach of telescopes and spacecraft. It was not a distant abstraction, but a tangible body, visible in images, measurable in spectra. theories could be tested, even if answers remained partial. Avi Loeb's beacon hypothesis found renewed traction when coupled with the Sagittarius alignment. What if the WOW signal and Atlas were not isolated coincidences but chapters of the same narrative? What if, across decades, the galaxy's heart had offered us breadcrumbs, first a fleeting radio transmission, then a material messenger? Critics pointed out the leaps of assumption, the lack of direct evidence, the risk of anthropocentric projection. Yet the allure of the idea was undeniable. It reframed the question of coincidence into one of connection. What if our cosmic neighborhood is more communicative than we think? Even within the naturalist camp, Atlas stretched imagination. If it truly carried nickel without iron, what kind of stellar chemistry birthed it? If it exhaled carbon dioxide so freely, what processes froze that composition billions of years ago? If its nucleus was so small yet so active, what hidden mechanisms amplified its behavior? Each anomaly forced revisions to models of cometary evolution, models that had been comfortably tuned to our solar system, but now faced the challenge of universality. Perhaps comets beyond our sun simply followed different rules. Perhaps the very definition of a comet required expansion. The conversation extended beyond astrophysics into philosophy. Was Atlas evidence that the universe is filled with wanderers, messengers of chance, carrying stories of other suns? Or was it a singular sign, a rare anomaly that happened to intersect with human history? Did its arrival underscore our solitude, an ancient body passing without word? Or did it hint at connection, a whisper from afar, awaiting interpretation? Scientists debated, writers speculated, the public wondered, theories multiplied, none proven, all shimmering with possibility. By early 2026, as Jupiter loomed on Atlas's path, these debates only grew louder. Data from JWST and Rubin filled journals with graphs and spectra, but between the lines of science, the questions of meaning refused to fade. Atlas was a laboratory, but also a mirror. In asking what it was, we revealed what we hoped for, what we feared, what we imagined the universe to be. Some sought certainty in models, others found poetry in speculation. All agreed on one thing: Atlas was not ordinary. The story pressed forward. Jupiter awaited, Juno prepared, dust grains poised to whisper secrets. Whatever Atlas was, natural relic, alien beacon, or something stranger, it was not finished with us yet. The speculation surrounding Atlas did not arise in a vacuum. It emerged into a landscape already prepared by two earlier visitors, two strange wanderers that had passed through before, each rewriting assumptions in their own way. To understand Atlas fully was to place it within this lineage, to see it not as an isolated anomaly, but as the third chapter in a growing cosmic narrative. 3 arrivals, 3 different tales, 3 pieces of a puzzle so vast we had only begun to glimpse its outline. The story began in 2017, when astronomers first detected an object moving too swiftly, too steeply angled to belong to the solar system. They called it One-Eye Oumuamua, meaning a messenger from afar arriving first. Its very designation reflected its uniqueness, the first recognized interstellar object. Unlike any comet or asteroid we had catalogued, Oumuamua behaved with a subtlety that defied classification. It showed no obvious coma or tail, yet its trajectory shifted as if some unseen force nudged it, a non-gravitational acceleration that could not be fully explained. Its shape, inferred from its light curve, appeared elongated, perhaps like a cigar or a pancake tumbling through space. To some, it was simply an icy shard whose outgassing eluded detection. To others, including Avi Loeb, it became the spark of a provocative hypothesis, perhaps a fragment of alien technology, perhaps a sail driven by starlight. Just 2 years later, in 2019, another interstellar traveler arrived. This one, designated 2I Borisov, bore a far more familiar guise. Discovered by amateur astronomer Gennady Borisov, it displayed a bright coma and a clear tail, behaving unmistakably like a comet. Unlike the enigmatic subtlety of Oumuamua, Borisov's identity was legible, yet even it carried peculiarities. Its dust and gas compositions differed from solar comets, suggesting that while it was familiar in type, it was foreign in recipe. Where Oumuamua unsettled with strangeness, Borisov comforted with recognition, while still whispering of distant stellar kitchens cooking their chemistry in different ways. Atlas, the third interstellar visitor, entered this sequence in 2025, and from the start it proved itself neither subtle like Oumuamua nor straightforward like Borisov. It was something in between, or perhaps something altogether new. Like Borisov, it bore a coma and tail, clear evidence of volatile ices sublimating in sunlight. But unlike typical comets, its behavior was amplified to extremes, its activity vastly disproportionate to its nucleus size, its chemical ratios skewed, its architecture more like a jellyfish than a snowball. Where Oumuamua had been too quiet and Borisov comfortably loud, Atlas roared beyond expectation. The comparison among the three revealed a tapestry of diversity. Interstellar objects, once hypothetical, now appeared not as uniform fragments, but as varied emissaries, each carrying its own story of origin. One mute and enigmatic, one familiar yet foreign, one explosive and paradoxical. Together, they suggested that the galaxy teems with variety, that planetary systems form and fracture in countless ways, scattering debris as unique as fingerprints across the interstellar medium. Astronomers began to speak of a pattern emerging, though not a pattern of sameness. Rather, it was a pattern of diversity, a recognition that diversity itself was the rule. If three interstellar visitors could present such distinct personalities, then the implication was profound. The galaxy must be filled with wanderers, each one potentially unlike the last. The statistical models reinforce this. Given the sensitivity of our telescopes, the probability of detecting three interstellar visitors in less than a decade suggested that millions upon millions more roam unseen. Most pass at distances too great for detection. A few, by chance alignment, swing close enough to be noticed. Atlas was one of those rare alignments. The diversity also carried lessons. From Oumuamua we learned humility. Our models of small body dynamics were incomplete. Our ability to interpret light curves fallible. From Borisov we learned continuity, that other systems produce comets much like ours, evidence of shared processes across the galaxy. From Atlas we learned surprise, that nature can amplify effects beyond expectation, producing paradoxes that challenge even our broadest theories. Together, the three formed a curriculum in cosmic diversity, a course in how to study what drifts between the stars. The growing catalogue of interstellar visitors also reframed the way astronomers spoke about the galaxy. Instead of distant stars being unreachable islands, they now seemed to send us fragments, drifting ambassadors of other suns. Each object was a messenger carrying chemical signatures, structural quirks, and historical scars from its birthplace. To intercept them was to intercept news from afar, a kind of galactic correspondence written in ice and dust. If three had already passed, then surely more would follow, each expanding our dictionary of what planetary systems can create. Speculation bloomed. Could we one day build missions designed to intercept such wanderers deliberately, rather than scrambling after discovery? Could probes be kept in readiness, poised to launch at a moment's notice, to chase down the next Oumuamua, the next Borisov, the next Atlas? The thought thrilled engineers and mission planners. For the first time, we were not merely passive recipients of interstellar debris. We could imagine becoming active participants, meeting the messengers rather than merely watching them pass. The statistical likelihood pressed urgency on this vision. If detection rates had already yielded three in less than a decade, then with more powerful instruments like Rubin scanning the skies continuously, future discoveries might become annual, even routine. Routine, yet never ordinary, because each visitor promised to be unlike the last. The galaxy's library was opening, book by book, and Earth had just begun to turn its pages. Atlas, as the third, carried symbolic weight. 3 is the threshold of pattern, the point at which randomness begins to feel like rhythm. A single anomaly can be dismissed. A second suggests possibility. A third insists upon reality. By its very arrival, Atlas shifted interstellar visitors from curiosity to category. They were no longer flukes, they were part of the structure of the universe we inhabit. We lived not in isolation, but in a cosmos crisscrossed by wanderers, an interstellar commons through which bodies flowed as naturally as rivers carve valleys. The realization altered our sense of place. Earth was not a closed world, nor even a planet orbiting in quiet seclusion. It was a node in a vast traffic of matter, a brief host to visitors from other suns. The heavens above were not fixed but permeable, porous, alive with motion. Atlas's arrival underscored this truth. Humanity, for all its telescopes and theories, was just beginning to recognize the scale of the dance it had always been part of. Looking back, each visitor felt like a chapter in a story still being written. Oumuamua, the enigmatic messenger, raised the question of what forms interstellar debris might take. Borisov, the familiar comet, answered by showing both similarity and difference. Atlas, the paradoxical roarer, complicated the narrative, reminding us that exceptions may outnumber rules. What comes next is unknowable, but what is certain is this: there will be a next. Already telescopes scan the sky, searching for the faint motion that betrays another traveler. Already mission concepts circulated, envisioning spacecraft that could intercept within months rather than years. Already theorists drafted models to predict distributions, sizes, and chemistries of future interstellar wanderers. The puzzle pieces were scattering across the table, awaiting our effort to fit them together. Atlas, as it drew farther away, carried its mysteries with it. But its greatest gift might not be the answers it provided, but the questions it multiplied. Questions about the galaxy's diversity, about survival across eons, about the likelihood of design, about the richness of interstellar traffic. Questions that would not end with its departure but would flow onward, seeking the next arrival to test them. 3 visitors, 3 different stories. The galaxy had begun to speak, and the cadence was unmistakable. Somewhere beyond Jupiter, Atlas was already fading, but the pattern it had helped establish only grew brighter. Another would come, and another after that, until we no longer thought of these wanderers as rare intrusions, but as constant companions, the galaxy's quiet reminder that we are part of something vast, ancient, and unfinished. The puzzle had expanded, but the final piece was still missing. The third arrival was not the end, only the threshold. Beyond the horizon of time, the next wanderer waited, carrying secrets we could not yet imagine. Yet Atlas, the visitor of 2025, had already begun to slip beyond our reach, retreating into the deep interstellar night from which it came. Its departure was inevitable. That had always been the truth hidden within its trajectory, the immutable fact written into its velocity. At more than 30 kilometers per second relative to the Sun, Atlas was on a one-way path. Gravity would never reclaim it. The solar system had brushed against it for a brief season, then watched as it continued on its endless voyage. To speak of a farewell was to acknowledge the transient nature of all encounters with interstellar travelers. They arrive unbidden, they reveal what they choose in the short window we are granted.
While astronomers debated coincidences and patterns, the sky itself was preparing its next revelation. It did not come as a shout, but as a flicker of fragile mark across a field of stars. It was May 2025 when the alert first appeared, far above Earth, in a quiet orbit. The Transiting Exoplanet Survey satellite beta, known as TESWAS, carrying out its patient vigil. TESS had not been designed to hunt for interstellar comets. Its mission was something more methodical, more subtle, to watch thousands upon thousands of stars, searching for the slight dimming that occurs when a planet crosses in front of its host. Like a cosmic census taker, it recorded brightness levels with unblinking precision, seeking patterns invisible to the human eye. Yet, in science, discoveries often arrive sideways. What Tess noticed was not a planet passing in front of a star, but a faint speck moving where no speck should be, against the backdrop of constellations that had held their places for millennia. One point of light betrayed itself by shifting ever so slightly between frames. At first glance, it might have been dismissed as a glitch, a piece of noise, an artifact of data. But the algorithms designed to comb through TESS' endless stream of numbers flagged it again and again. Something was out there, moving against the fixed vault of the sky. Detecting such a thing is no small feat. Our solar system is a crowded stage, filled with asteroids and comets tumbling along predictable orbits. Yet interstellar objects, those wanderers not bound to our sun, are almost unimaginably elusive. They are small, dark, and fast, slipping into view only when chance aligns their paths with our instruments. Spotting one is like trying to notice a firefly darting through the heart of a thunderstorm, its flicker drowned in the lightning all around. Yet somehow, in the spring of 2025, the firefly was caught. TESS had acted like a lighthouse in the dark, sweeping its beams across vast regions of the sky. By comparing the brightness of countless stars over time, it revealed the faintest disturbances, the most delicate shifts. In this case, it had illuminated not a planet, but a travula, faint betraying its presence through motion. It was, at first, little more than a suspicion, a whisper that something unbound had crossed into our awareness. What made the discovery remarkable was not only the detection itself, but the distance at which it was made. Early estimates placed the object more than 6 astronomical units from the Sun, 6 times farther than Earth, out past Jupiter, still on the cold outer edge of our planetary family. At such distances, ordinary comets remain dormant, frozen solid in the deep freeze of interplanetary space. Yet this object, faint as it was, appeared active. Its coma shroud of gas and dust was already awake, spreading a thin veil around its hidden nucleus. That detail set pulses racing among astronomers. Cometary activity so far from the Sun is rare, especially for small bodies. The heat of our star usually has little effect at such distances where sunlight is weak and surfaces remain locked in ice. For a newcomer to reveal itself with signs of activity at 6:0 suggested an unusual volatility, a chemistry unlike the comets we know. It was as though the wanderer was eager to announce itself, unwilling to remain hidden until it drew closer. The implications were extraordinary. An interstellar object, already active, already distinct, spotted earlier than either of its predecessors, Oumuamua and Borisov. For once, humanity had time to plan observations, time to mobilize telescopes, time to study a visitor before it rushed past and vanished into the night forever. Word of the detection spread quietly at first, confined to research groups sifting through test data. But soon the murmurs reached the broader community. Emails lit up, observatory schedules shifted. Teams began to debate trajectories, brightness curves, orbital possibilities. It was too early for confirmation, too soon to declare the object object unbound. But the excitement was unmistakable. Something unusual had entered the stage. Picture that moment. A handful of pixels buried in a sea of numbers, coaxed into meaning by algorithms, then spotted by human eyes trained to suspect the improbable. A speck against infinity, barely distinguishable from background noise, yet carrying within it the potential to reshape our understanding of the galaxy. This is the essence of astronomical discovery, not always dramatic images,